Hi, welcome to this tutorial on the validity of the binomial expansion. Now, if n is not a positive integer, then the expansion is only valid for values of a between -1 and 1, and the series also is infinite. Now in exam questions you're going to be asked about the validity of a binomial expansion. So for instance, suppose you had to look at the validity of, say, the square root of 1 minus 2x. If we were to use the binomial expansion for this, I would need to put this in the form 1 minus 2x to the power a half. And you can see that the power is not a positive integer. So if we did use the binomial expansion, it would be infinite, but it would only be valid for a particular range of values of x. So to find that set of values, let's just put down here valid if. Okay, now it's valid if the a value, which in this example is minus 2x, lies between -1 and 1. So we can say that it's valid if minus 2x lies between -1 and 1. Now what we need to do is find out about x, not minus 2x. So I need to remove this -2, and so what I can do is I could divide throughout by -2. In other words, we've got -1 divided by the -2, which is plus a half. But we've got to be very careful, because when we divide by a negative number, or for that matter multiply by a minus number, we must reverse the inequality, so that changes. Now minus 2x divided by -2 is going to be simply x, and 1 divided by -2 is going to be minus a half. But again, because we're dividing by a negative number, across the inequality, reverse the inequality sign. Now what we have here is that this number is less than the number over here, so you should always have the smallest number in an inequality on the left hand side. So what we can do is swap this round, and we get that minus a half is less than x, which is less than a half. In other words, x lies between minus a half and a half for the binomial expansion of the root of 1 minus 2x to be valid. Okay, well, let's try another example. Let's try a fractional one. Let's suppose we had something like 3 then over 2 minus x. Now if we had this kind of term to expand as a binomial expansion, we would need to bring the 2 minus x up to the top. 3 bracket 2 minus x, and it would be to the power -1. Now it's not quite in the form of the binomial expansion, because we need a 1 here, and we've got a 2. So in other tutorials I've shown you how you can adjust this particular bracket, but I'll just quickly run through it again just in case you're not sure. What we do is we pull the 3 out here in front of a square bracket, and then whatever number we have here we pull out in front of another bracket. We put a 1 here so that 2 times 1 is 2, and then we write minus x over 2 so that 2 times x over 2 gives us that x. Alright? And all this is to the power -1. And then each of these parts in the bracket here are then raised to the power -1. So we have 3 multiplied by 2 to the -1, and then 1 minus x over 2 to the power -1. Now it's this part that we're interested in. This is the part that we would use the binomial expansion formula for. Notice how the power -1 is not a positive integer, so that means that the series would be infinite, and it's only valid then if the a term, which is minus x over 2, lies between -1 and 1. So therefore what we can say is that this is valid if minus x over 2 lies between -1 and 1. So to work out the range for x, what we need to do is get rid of this 2 here, so we could multiply throughout by 2, and if we do that we would get minus 2. We're multiplying by a positive number, so the inequality signs do not have to change, so that would be minus x and less than 2. But now I need to get rid of this minus, so we could multiply through by minus 1, and if we do that we're going to get 2, and remember to turn the inequality round because we're multiplying by a negative number, and then we'll get x, reverse this sign round, and we'll get minus 2. Put the smaller of these two values on the left hand side, so we need to swap this all around, and we would have minus 2 is less than x is less than 2. In other words, x must lie between minus 2 and 2 for this binomial expansion to be valid. Okay, well, I hope you've been able to follow what I've been doing here, and you can use a similar idea if you're asked to work out the validity of a particular value of x, okay, the range that it has to lie between. Okay, so that brings us now to the end of this tutorial.